So thank you very much. Vielen Dank. Ich glaube, ich muss sagen, ja? Yeah? Okay. Got to show off my German. So thank you very much. We have a really interesting panel here today. I'm going to take a seat there. I'm just going to kick off. Oh, go ahead, please. Oh, I guess I'm going to have to stand up here now. I don't get to do what we call the Llewellyn technique, which is sit on the corner and not be center of attention. I apologize. In any case, let me provide a brief introduction. We'll go from my right to left. We'll start with Martin. Martin, you want to introduce yourself?
Sure. Lieutenant Colonel Martin Salinas with AFWERX Austin. So we've got a hub over here in the local area. And background is B-52s, worked in operational test. I was involved in the Agility Prime program, which was the kickoff with AFWERX on flying cars, and then moved over here to the Austin area as we grow that capability here in the local area, and look forward to working with all the people of good Austin and Texas. And by the way, I went searching for my Aggie ring, took it out of my bag, but am an Aggie, so this is coming back home for me, and happy to be here.
Yeah. But he's not wearing the Aggie ring, so any Aggies in here, I mean, really give him a hard time about it. Feng?
Okay. My name is Feng Wang, and I'm an associate professor in civil engineering in the School of Engineering, Texas State. We have a civil engineering who knew, and for a couple of years, starting recruiting students, educating students in 2019 fall. Right now we have 300 students, so we're in rising. That's a good part. My background is in transportation engineering, so today's topic is quite relevant to my background. And we also feel, I appreciate Dwight's presentation, and especially he introduced to his experience and sharing some of the points in technology in transportation area, so which is happening in this country and everywhere, I believe. Austin is a hub for technology, so we are excited about the opportunities in here. So, and I'm just quick introduction myself.
Yeah, thank you. Okay, and next one, I love his name because you can call him one of three things and he'll answer to it. It's Jason, John, Michael. So you can call him Jason or John or Michael. He answers to all three.
Yeah, or you can make up something that involves those three, and I'll probably answer that too. Hi, everybody. I'm Jason JonMichael. I'm an Assistant Director of Transportation at the City of Austin. I am the smart mobility guy. I am the self-driving car guy. So within my portfolio is the smart mobility office, which is piloting and beginning workforce development and planning around what the city's level of give is, or what our part is in enabling a lot of private sector autonomy and mobility through mostly mobility as a service solutions. And then in addition to that, I'm also in charge of the parking enterprise, travel demand management, which is about really trying to bring around environmental sustainability to our transportation system. We started off with just trying to get people to carpool, but it's a lot more than that today. The placemaking program, which is this intersection of creating safe shade equity, for instance, since we're in Central Texas, in our transportation environment for transportation users and transit users, and then also, and then finally, regulation of all those mobility as a service solutions.
All right, thank you very much, Jason, John, Michael. And Dwight needs no further introduction. And finally, Darran Anderson.
I'm Darran Anderson. I'm the Director of Strategy and Innovation at the Texas Department of Transportation. Effectively, I'm Jason's counterpart at the state level. And my responsibilities include looking at emerging technologies, both for direct applications for the department's use or needs, as well as their influence on what the department's missions are and the mobility space. So everything emerging technology, to include eVTOL, to include AV and EV and Hyperloop, and you name it, those are all the areas that I focus on, and then bring that to the department for further strategies and efforts.
Thank you, Darran. And I'm going to now put Andreas a little bit on the spot here because Andreas, I would love to say I put this whole panel together and it's a wonderfully diverse panel, but we have one empty seat, Andreas, and you left an empty seat. And what would have been perfect would have been have somebody at the federal level. Would have been, perfect. So I'm just make a note next year, dig a little deeper in that, 10,000 person Rolodex of yours and well, I think you would have been overwhelmed by this panel in any case. So with that, we got together in advance and talked a little bit about this panel. And we wanted to come up with a theme. And rather than kind of talk about the theme, I'm going to ask our AV guys, that's you back there, AJ, to run give a little 30-second vignette that I really want to use to set this this whole panel up. So go ahead, AJ.
Your move, Captain.
We should have intercepted by now. The bridge said they'd call.
I'll have you checkmated your next move.
Have I ever mentioned you play a very irritating game of chess, Mr. Spock?
Irritating. Ah, yes. One of your Earth emotions.
Thank you very much, AJ. The reason I wanted to show this, when we sat down and we talked about transportation in 3 dimensions, when I think 3 dimensions, I always think of the Star Trek three-dimensional chessboard. So I want to kind of use that as our theme of thinking about, we talked about Hyperloop, we talked about what some of the things Austin is doing below ground, at ground, which is, the traditional XY coordinates, if you will. And then, of course, we have the Z-axis, and we have a few people here who know a thing or two about the Z-axis. I wanted to think about this as transportation in 3 dimensions. And the first question that I really want to ask to the panel, as we talk about this 3-dimensional aspect, and it'll be interesting because I think we'll get very different perspective. What is the only one, you only get one, Jason, technology challenge, development, etc., that has to be met in order to achieve this 3-dimensional transportation vision? Just one technology challenge. And I'm going to start, Darran, I'm going to put you on the spot first to ask you.
I think one of the ones that's always at the forefront of what I think is the digital infrastructure. You hit on the infrastructure, the backbone that will enable a lot of that through the communications and cross. You heard a lot of that, talked about not only just now, but earlier today, the ability to enable that communication effort that supports all of it.
So GPS isn't enough?
No, it's not.
Okay. Dwight, one thing.
Yeah, I would concur with that. I think in the panel prior to this, using HPCs from a latency standpoint is going to be really important for autonomous operation. Okay. Now, I'm hoping we get a couple different perspectives. I don't want everybody to say it's all, HPC sensors and the digital management infrastructure. So I'm counting on you, Jason.
Well, that's part of the build, right? And it's an important part.
Okay.
And I look at it because I'm a systems integrator by trade, right? So I think about it from the systems of systems perspective. And part of that is, thank you. And part of that is really trying to figure out what is the intersection of those systems. And usually, I hate to say it, but as we look at things around how to take and connect autonomy to different parts of the physical environment, that old 80s and 90s analogy around middleware starts to come back up again, right? Around what are the systems that are in between the systems to make sure that flight systems are connected to safety systems, that are connected to ground control systems, that are connected to the air systems itself. Those are where I see a lot of those things. And that's where folks like Michael DeCourt, for instance, and some other folks are really starting to help the FAA and others really push that forward.
Wow. Now, part of that would be APIs, using kind of a well-worn term, sort of transportation APIs. Is that kind of where
yeah? I
you're
mean,
going
if you think about like what the current controlled environment is and where we want to go, there's all these new systems that are both on vehicle or systems that support the overall airspace, or eventually those vehicles need to access ground, right? And so how that looks, where that happens in the city, it is about communications, but moreover, each one of those systems is probably going to have its own unique roadmap and course, right? 5G has its own, other thing, electrification, et cetera, microgridding. How those things come together from a planning perspective is one thing, but when you look at operationalizing it, what are the systems in between that need to ensure that those systems work together immutably? Those are the key pieces in my mind.
Kind of a little bit back to that protocol stack we talked about a while back with Darran and you, and is there a transportation equivalent to the communications protocol stack? So Feng?
I think from just the word 3D, my first reaction would be data collection, because you just think about the air traffic controller. If you don't have the height and XYZ dimensions, it's just hard, because I know air traffic controllers, they have a flight levels. So you can have people, the aircraft flying different levels. And that is, I think easy, but it's not that easy to be done. So, and considering all those, suddenly everybody can drive their own vehicles or aircraft, and it's gonna be an air traffic issue. And a lot of data and a lot of technical issues will be taken care of. And giving you another example for my research, for TXDOT, they have been done this manually data collection on pavement, the roads. So you have holes, you have cracks, you have rutting things, all those, the bad, we call it distresses are happening on the roads. You need someone to measure, to evaluate. So for many years, we did this manually. And after 2017, we feel like we have to do this automatically.
Okay.
And they did the data collection initially with two-dimensional.
Yeah.
And now three-dimensional.
Right.
So with all this data and also expansion on dimension, and 3D really give us a lot of more, in a sense of work to do. Yeah. And this is really, people call it the big data, or how you can deal with all those, so much data, rich. So this is what we're doing.
So I'm going to ask a math question. Is the person, I don't see him here, the person who was with Dell earlier in the HPC, I don't see him here, but he brought up calculus. I haven't used calculus in at least 30 years. But is this, if by adding that third dimension, does the complexity go up by the cube of the data or more? I'm just kind of curious.
Much more.
Much more than the cube of the data.
Yeah.
So
and the computers and the software, everything related will be quite different.
Okay.
Yeah.
Well, this is all good news for our ARM friends. I'm looking for my ARM friends there. This is all good news for you guys.
Yeah.
Continued growth market.
For civil engineers, we used to be just dealing with structures, strengths, mechanics. Now we come across the border to taking electrical engineering, computer science, that kind of things. That give us more demands.
Yep. Okay, and Martin, this should be an easy one for you, because this is the world you live, is identifying and assessing technologies.
It is, and I think the panel's covered the big ones, and I think the ones that are on our minds right now, so I won't repeat those. I will say that, to go a little bit with your example, maybe to be slightly irritating, right, as the three-dimensional chess was irritating to Captain Kirk. One dimension we have to think about is and a challenge, maybe it's not a technological challenge, but a challenge to the technology, is public trust and adoption, right? So that is going to be a humongous challenge for all of us. We're already seeing it in what we're working with. I would probably poll this audience and ask how many would get on an airliner that was automated, right, with no pilot at the helm.
Well, ask that question. How many?
Yeah. So how many today, right now, would get on that aircraft? So I would say this audience is about, what was that?
By the way.
50, 60%, 50% of the audience. Now granted, this is a biased audience because you are technologically interested. And I will say there are people even within my organization who say they would not do that, right? And what does that get back to? So that gets back to what I think some of the challenges that a lot of the folks in this industry are facing is that technology has to be mature enough, right? It has to be developed enough and then to the point with enough data behind it that reliable enough that the public will embrace it. But we're talking more than just trust in using the data. It's also trust that or using the technology, but that the technology will be used in a way that's acceptable even to the public, right? So if we use advanced air mobility only for those with advanced means, right, you now isolate folks, and that could be a challenge. If people think that technology is being used in ways that are breaching of the public trust, where perhaps their privacy or other things are being impacted, that's also a problem. So, I think one of the things that a lot of the folks involved with this technology are thinking about is bringing the public in, as much radical transparency as possible. As you develop the technology, keep the public close to it, and continue to find ways, even policy-wise, right? Policy is another one we could talk about. That's a challenge to the technology. And to continue to think about how we build that trust and adoption.
Well, now I'm going to embarrass John. See, I'm going to go Jason, John. I'm going to use all your names now. I'm going to use all of them, and we'll see if you respond. But I think it's fascinating that the person who, based on title and job role, should be most focused on the technology, actually focused on the human element, and yet you are probably closest, in all deference even to you, Darran, to the human element, because you are really moving people around every day.
And I may have answered the question wrong. I thought it was about what the technical challenge was. I thought the technical challenge was, in fact, the system and the intersection of many systems coming together. From the adoption perspective and public trust, I think here's one thing I'm going to put out as a message to everyone. You're seeing what's happening with the level of additional hype that was too early related to land-based autonomy.
Yes.
Can we not repeat that mistake again, please? Because that's, as a city, that's what I've had to deal with the most, right?
Well,
getting the community to understand, oh no, they were just kidding. This is really where they are.
Yes.
Right? Like that part is, I need everyone's help in that. I can't do it all on my own.
And I'm gonna pivot to that now, relative to this whole autonomy thing, the two-dimensional autonomy history and where that goes. And one thing I want to do, in case not everybody is familiar, you brought up, L5 autonomy, et cetera. I don't know if people know that at least in two-dimensional autonomy, they have 5 levels of autonomy. L0 is what we do today. Everybody driving their own car, human-based control. And if you want to think of L5, means you get into a vehicle that doesn't have a steering wheel. There's no potential for human intervention. And I guess the Tesla, the GM Super Cruise or the Tesla autonomous driving really is more of a level 3, 3.5. Is that where you would maybe put that?
Yeah, absolutely.
So within that context of that and asking that question, how do we position this third dimension, the vertical dimension, and not make the mistakes we've made so far in setting up, a huge hype curve relative to vehicular terrestrial autonomy? So, and we'll start with, I'm going to put you on the spot again, Darran.
Oh, really? Okay. Well, one, I think, I'll speak a little. The hype is somewhat essential in that it drives other activities. But, so for example, the hype has driven in this last legislative session, we were directed as a department to begin to examine state laws that might impact or impede the ability to advance the technology, or what other laws might be enacted that could support the advancement safely and smartly. So we've just started on that initiative, and without that hype, that probably wouldn't have happened in this session. It might have taken a few more. But I agree with you. If they overhype it, then there's too much promise, and in the inevitable, realization of where the industry really is in its development and its readiness comes to fruition, and then you have the trough of disillusionment, as they call it. And so I don't know if it's just more of being open and honest repeatedly with where you are, but it's a challenge for any entrepreneur, because you do want investors, you do want to encourage people to see that there is a potential and a reality that this will come. So how do you balance that without overstating it?
And I'm going to take that point, and I'm going to run a little bit with you, Dwight, in terms of specific place where you've chosen to use as your test bed, which is Brownsville, Texas. Anybody who was here yesterday heard a little bit about Brownsville and the relationship. But Brownsville has these things called resacas. Now, I don't know, I suppose that's the Puerto Rican, but I don't know if resaca, what that means in Spanish, or if it's a Spanish word even. All I know is they are canals that run along that are kind of like safe right-of-ways, right? Because there's obviously nothing in that airspace, and as you described, they're great places to work with non-human autonomous vehicle delivery systems, so that if something goes wrong, it's not catastrophic. Can you talk a little bit about that, and how that you're using that as a stepping stone to create this trust?
So the resacas in Brownsville, basically they're kind of like tributaries from the Rio Grande Valley, from the river, and we use those because we just don't feel that our technology yet is at a point where we can trust it on its own. And we're using that for our smaller drones. We're going to be using that this year, because in the event something goes wrong, it falls in the water, we understand we can retrieve it, or do whatever. When we start doing delivery of our, what I call the 3Ms, which is meals, mail, and medicine, we will be operating about 80 to 90% of our flight time over water, open waterways. And so that gives us an ability to kind of crawl, walk, and run before we land in someone's backyard, not on their front porch. I think that, you've probably seen the Amazon and Google commercials, or not even commercials, just the YouTube or the marketing materials. I don't know how you fly in someone's porch and deliver something safely and then get out of there. We got to have a real conversation someday about what is real and possible and what is science fiction. There's so many things that can go wrong on people's porches, whether it's a chair, the cat on the porch that wants to jump up and grab the drone, some kid with a baseball that wants to hit it. I mean, we just have to be realistic about the application and what we can and cannot do. I believe right now, the way Brownsville is set up, it is the most ideal scenario to fly to someone's backyard, alert them when the delivery is there. We create a special landing pad. We have our own proprietary system that we will share with everyone that has transparency with the FAA, government agencies, et cetera, that we're making deliveries, and here's the remote ID tag to that. And then when it lands and takes off, we did our own system where it does a vertical landing and takeoff, even for the drones. We don't do that splash landing that you see with, once again, my competitors, where they just fly right in and just splash on your property and drop it off and take off. I don't know if you understand, but with aviation, it's the takeoff and landing is always the most crucial time for accidents. And so when you're doing that, you could splash on a pad and slide right off into the grass. You could hit a kitchen window or even the light pole and kill the whole power in the neighborhood. I mean, these are things that literally can and probably will happen. I want to go back to what Darran said earlier, and what you were talking about, the trust between autonomous transportation and people. There has to be a crawl, walk, run approach in that as well. And what Paragon is doing and other companies are probably doing or may pursue is we're going to have pilots in all of our large VTOLs when that time comes. I just don't trust a 4,800-pound projectile flying over my house, my building. I mean, haven't we seen 9/11? It's a scary time. And so having a pilot on board, they're there for emergency backup in the event something goes wrong. And so you're creating new job opportunities for kids coming out of school that can work a joystick. They may want to go into this industry. There's an opportunity there to really take the technology to levels where you're still you're babysitting it. If you look at your plane today, the pilot by and large, he's babysitting the aircraft.
Yeah.
He's there for takeoff and landing. The rest of the time, it's basically on autopilot. And so we've kind of gotten used to that. And by the way, since we're talking about airplanes, you know the wings are glued on, right? Just a little FYI. Anyway.
I'm going to pivot now back over to Martin here, as we've kind of brought up this. It's very interesting because you've talked about drones as we traditionally think of drones are remotely controlled devices, but there is a certain degree of autonomy in those drones, et cetera, and obviously the Air Force has a lot of experience with that. Relative to what you heard about the opposite of the Silicon Valley statement of fake it till you make it isn't going to work in this environment. What do you think the Air Force in particular and your division might be able to bring in terms of advancing that and taking the drone learning and now extending it into higher levels of autonomy?
So I think it's important to delineate. There's so many things to talk about here, but the differences, right? We talked about the levels of autonomy, but
right.
One, I think we're very careful even within our organization to be deliberate about saying what is automated versus autonomous, right? Because they have very different implications.
Excellent.
So I would say that's part of it, is being very deliberate on, what are the expectations? And Dwight brings up a lot of great points on what can be automated, what can be autonomous. So, an autonomous system, we imagine it's making decisions. It's changing based on stimulus in the environment. And maybe rerouting itself or coming up with a different plan. Like I don't think we're there quite yet. I think our aim point is something like 2030 and beyond, when you're actually going to apply those systems in public. So right now, more automated with autonomous features or maybe autonomous behaviors are some of the things that we're looking at. And even to get back to other things we're looking at, another thing that Dwight brought up that I found interesting too was the idea of the operator. I don't even want to say pilot, right? So what Dwight also brought up in his speech, which was great, the scarcity of your traditional pilot, right? The reason why that's important is a lot of reasons. One, economies of scale. Paying a $350,000 salary for a sophisticated pilot with traditional training is not sustainable, right? For these, when you start the scale that you go to bring this to reality, commercialization and operationalization, it won't happen, right? Even as we looked at the Ubers and whatnot who looked at this technology early on, even had that in mind. So one of the things we're looking at as simplified vehicle operations is a very important part of our analysis of the systems and the companies that we deal with. I always ask them, what is your operation schema for this aircraft? Is it simple to use? If I let go of the controls, will it just hover? Because when you think about that person that we bring in, the future, my 15-year-old or whoever, they need to be able to operate it with the ease they would operate a drone, with the ease that they play their video games, right? With those sort of things is what people are going to expect. The next generation is going to expect that simplified vehicle operation. But you also have to expect you're not going to be able to, from a market perspective, pay them $350,000 an annual salary to do those kind of things. But that will come with that ease. Now you can bring more people into that market, right? So that's very important to us. We actually have a detachment in San Antonio at Randolph at 62, led by a colonel who's looking into how do you train that next generation of simplified vehicle operators, right, for those sort of things. So that's something that we're thinking about. And I'll drop or stop on one point, hype. I think that's a great point to bring up. So we think about that a lot. Here's why and everybody brought up great points, because you do need a little bit of that hype. You've got to get people excited about the technology. You've got to be careful about overselling, definitely, because the expectation versus reality is important. But here's the other side of that coin too. There's two parts. One, even from our perspective, when we are taking small bets with multiple industry partners, our incentive from a military perspective, from a government, from AFWERX perspective, the reason why we do open topics and we have a lot, we compete out, we don't do necessarily focus topics is We want to make sure the U.S. leads in technology, right? And we're not necessarily anymore, we're not the top. We're not the top of the heap necessarily. There are other countries who are doing a really good job of probably, some would argue, have surpassed us in some technology sectors. In order to do that, we're having to go after that next thing, right? So that's really where our focus is where's that next thing where we need technological leadership in the United States, and we want to help, hopefully guarantee that. What that means to us, when you get back to the hype, is no one's asking for that thing, whatever that is, that widget that we find that's maybe that DJI drone of like 2006, 2008. Nobody back then envisioned that would take 80% of the market in the globe. And now if you want to buy a decent one, you have to buy a Chinese drone, right? So what we're trying to look for is what is that next thing? What that goes back to is we're in an interesting situation where now we're having to think as business developers, market makers, and convince those people that this is that next technology that's important. So not necessarily hype, but more from the perspective of now we need a mandate, right? We need and we're looking at this mandate from the federal government, mandate from our leaders to say, in order for us to continue, if you believe the United States should lead in technology, if you believe that that's an assumption or that that's valuable, then we've got to go after those technologies. We have to set that moonshot mentality out there and say, not to hype it, but to say it's important for us to go after it and important for us to make sure it succeeds.
All right, perfect. Now, I'm going to come all the way back to your very beginning where you made the comment about what is automatic versus what is autonomous. I thought that was, I've never quite grokked that there is this huge difference. Because, a lot of transportation systems, we talk about rail systems. Austin is working on Project Connect and looking at, rail systems are really automatic systems. They're not autonomous. They follow a set of rules and effectively a state machine. So Feng, I want to ask you, without a lecture, we don't want, you don't have 50 minutes here, you have 1 or 2 minutes. How do you integrate the automatic and the autonomous? I'm just curious, because are there other analogies where we are integrating autonomous behavior, independent autonomous behavior, with automatic behavior? And if you can just comment on that.
That's a good question, actually. I have a PhD students working on her dissertation was to look at the behavior of autonomous vehicles and connected vehicles. One day we have those vehicles driving on I-35, our network. And there's a process you call a penetration rate. Okay. How much percentage of the vehicles driving on the roads are that kind of autonomous and connected vehicles, and also our traditional vehicles. Right. So how can they work together? And so that's a good question. Actually, a lot of research and investigation should be done, and not just on the paper, not in the simulation. We have to go through that process we call a pilot. Yep. So you have to test. I know UT Austin, mechanical engineering. There's at least one faculty member. They are testing those ideas. They call a prototype ideas in their Pico Center. I would say those are great things for us to know more. And as engineers, we build. And we build things with confidence. Otherwise, you see this thing good, pretty, beautiful, we hesitate and to accept it. So one day we've tested everything with confidence, we can accept it. So that's how we make things work in engineering. So I would suggest a lot of research, including investment in research dollars, to be done by different sources like government, right. And also we could have money from industry as well to go into that, give us the opportunity and also time to test everything, every concept. By the way, our university is in a very unique and favorable condition. because we are not in Austin. So we have a lot of land in here. And San Marcos is ideal location for those test ideas to be implemented in here. So, so if any of you have this kind of a concept and you feel like this is something you want to do, and please consider Texas State University and also San Marcos in here.
Darn straight.
Now, I want to take one, you brought, you have a question?
I do.
Please state your name first again.
Darth Vader, I was told I was called yesterday. No, my question is, thank you very much for being here today. My question, it seems like to go with the vertical axle and maybe even a tangential axle, even with time travel and what have you is coming. We really need to do a great job of making sure that the use cases and the integration with fixed infrastructure and mobility and autonomous and all these things and connectivity, that it can really be tried not just in a little space like this one, which is a big space, but really out there, in the infrastructure. So if I told you that you have a corridor from Round Rock to San Antonio that connects through Seguin all the way to Brownsville, and that all those places are members of this consortium called CEDAR. Most of you are not on the stage yet, but many of those other places, utilities and cities are already. Would it be helpful to really join that and really build at scale, flying pads and recharging stations and autonomous shuttles coming and going 24/7, 365? Is that a kind of a playground that we need to sort out all these problems?
I would love the playground, especially something that's south of Austin. That would be great. That's not in the middle of what makes Austin, Austin, for instance. And I think that's to Martin's point. Having a mandate's important. Having scenarios is important. I look back at land-based autonomy, autonomous vehicles, and I see how the pile-on of extra scenarios helped create really, and when you think about the hype curve, don't think about the hype curve, think about the trough and then how you dig yourself out of it. I think of it's like Price is Right, it's a little mountaineer game, and then you slide back down, right? After you come over the crest, you're all the way down at the bottom and then you got to dig your way out. So the more mandate on clarity that we can provide for things that are most important to our country to ensure that we do win in this new foray of technology and start to take advantage of that's where I think that we need that level of clarity. With the mandate usually comes some dollars, but it comes with clarity. Clarity helps provide good, easy, understandable ways for private sector to take on that level of investment. And that's the things that Dwight needs, right? Those are the things that we need in government as well. Because if I can provide that clarity, then I can easily tell other people that want to pile on and add on so much mud to the thing that it doesn't matter how much we flap our wings, it ain't going to fly or soar. That to me is that key element. And to answer your other question around how do we work out this issue between highly automated systems and autonomous systems, it's you and me. Humans are going to be in the loop for a little while longer, y'all, and so that's the whole reason behind that is that we're still going to have to help make sure that these systems can interact with one another. And that's where I think an operator comes in, and highly automated, it may have highly automated takeoff and landing tool sets, and it may have a fully autonomous, mid-air flight, right? And what's the one thing in between that? That doesn't necessarily mean that somebody has to be in cockpit. They could be teleoperated in the future. So, but it still means that humans are still somewhere in this process for a while.
That's a huge, by the way, thank you, Michael. Notice I've used all three of his first names now. That's kind of an epiphany here that we didn't have when we talked before. And by the way, I think it's going to be fascinating putting these 5 folks together, because when we talked on the phone, as soon as we got done, they basically cut me out of their conversations, and they're having lunches on their own and everything else.
Oh, come on now.
You know, my work is done in effect. You guys are already off and running with this. But I want to turn to Darran because, you know, I'm going to ask, you know, it's the old saying, and I'm not going to pick on Martin over there because he's a technologist, but you know, I'm from the government and I'm here to help, right? What is it that at the state level, and you know, you can, you know, if you want to talk for the federal level as well, we won't, you know, it is being recorded, so you could get in trouble for that. But what is it that the state can do relative to everything we just discussed here about creating a test bed, being able to, you know, not do a flash cutover of autonomy all at once, how we're going to intermingle this? Where does the state come in? You talked a little bit about policy and what's happening at a legislative level, and ultimately there's the politics of this.
Right.
So can you maybe talk a little bit about that?
So I know you're going to have a discussion about innovation corridors, I think, tomorrow. But it struck me on his question. I mean, we're all in on that. I mean, we want to advance innovative, you know, mobility solutions to include eVTOL, and we want to understand it. We want to know where it is, as we talked earlier, where it is in progression. So enabling that, setting the conditions for that, that's exactly where we want to be. I think a lot about, you know, the question, it can't just be purely for research and development. I think that companies are certainly interested in that, and you could relate this to the, you know, ground-based AV systems as well. But they have to know that there's a business opportunity along that innovation corridor, or multiple business opportunities, because at some point they have to begin to make some kind of money as they continue to do the necessary research and development to get to where their long-term vision is. So we want to support that. We want to enable that. We try to get them you know, time with the legislature to make sure that the legislature is educated on where the community is. And I think that's the same thing that's happening at the federal level. I mean, they're pushing their initiatives and their strategies to enable that kind of conversation to happen as well. And we just, a lot of what I do is more facilitating the conversation and letting the right people solve the technological challenges, and then making sure that in our case for the state, we're supportive. We're not restrictive to the extent where they can't advance. But at the same time, we represent the concerns of the community in the cities and regions of the state.
Okay, well, I want to go with a little further, you know, looking at the Z-axis again.
Right.
And when we traditionally think of the regulation, the management, let's not use regulation, let's say management of that space, you know, the three letters always come up, FAA,
Yeah.
okay? And we were having this discussion, and nobody's been able to give me an answer to this yet across the panel, so I'm going to challenge them again, is, you know, when you look at the FAA, it manages airspace nationally, including intrastate, not just the interstate, but intrastate. What are the abilities at a state, county, and municipal level to control that airspace and dictate that airspace vis-a-vis the federal government? I mean, hey, we're in Texas.
All right, so this is my opinion. I'll give you a two-part answer. One, the FAA certainly regulates airspace for commercial aviation, and generally regulate, I'll say generally regulate, and I look to AFWERX to back me up if I'm right, generally regulates the rest of the airspace, in that general aviation traditionally is operated on you know, visual, you know, identification, so visual flight rules. And so if you think that they're, you know, regulating the airspace to the, you know, technical level detail that we're talking about with drones on a daily basis, they're not. And they recognize that that's a challenge for them. And so there is a lot of question about what's the future of how that would be managed, and would states have to establish essentially another FAA at the state
That's
level.
where I'm going. Equivalent to what we do with power today.
Right, and we don't know yet. There was a bill in the legislative session that didn't pass. It talked about navigation easements, so air highways, if you will, or airspace management is really what it was getting after at the state level. And so I think that's important of things to come. You know, what might the state have to do in the future, but right now we don't know because it's still wholly owned at the federal level.
Okay, well, I'm gonna turn to Martin, who gets his paycheck from the federal government to take the counterpoint here.
So no, I don't know. I don't have a counterpoint. I would say I have a yes and on that. It's an interesting. It's a conversation I just had with. I got back from NASA last week, and we're talking about the same thing. And don't quote me on this because this is going to raise eyebrows. But
turn off the video for a minute.
I agree. I don't think the FAA. I don't think the FAA has any interest in expanding that area of authority. I think they're going to want to leave it alone, and they're going to try to find a system that nests itself in that space outside of the space they're managing, right? So unfortunately, you nailed it. It's general aviation space, right? What does that mean? So that has huge implications. We're probably going to congest the GA space, right? That's probably what's going to happen. Again, I don't have a crystal ball. I don't have any authority over that. I'm just guessing that's where it's going to be. So the general aviation community is going to be very interested in what that means to them, right? There's a lot of interest there. How you share that space with other people. If I had to guess, there's going to be a system in place to manage it, right? There's going to be a see and avoid capability. The automated or autonomous systems are going to have to work with general aviation to deconflict. And I think that'll be a system outside of the FAA will have knowledge of it, but they won't necessarily need to manage it. They'll just need to be assured that it doesn't conflict with the space that they're managing. Operating, right.
Martin, do you think that they would maybe even get to so far as to say that there's certain characteristics? Because those systems would maybe even be geolocation specific, maybe even scenario specific in the GA space. Do you think that at some point in time, not immediately, but as we see that iteration happen, I'm sorry, Bill, I'm playing your role for a second because I had this question.
I know, I'm the moderator, man.
Is, would it be something where there's like a set core set of rules or requirements of those systems?
I think so. I think there'll be an architecture, an infrastructure system that exists that everybody agrees there'll be a standard. I think there may even be corridors, right? I think you're going to have complex corridors that exist, and you'll have to have and this is something we talked about last week was you'll have to have a system in place where an emergency management system of those corridors also, right? So, and it may be commercial systems that manage it. You may be like Verizon's and other AT&Ts that have their own management systems you subscribe to. We don't know. That commercialization is out in the open right now. It's out in the wild. It's ready for anybody to take on. And you'd have a scenario where that's there, but then if I have to, let's say in the future I have emergency management systems I can deploy within that system, which I think will be amazing and it would be valuable to all of our public, where I could launch a paramedic in a VTOL of some sort, VFR direct to the place where they need, passing up traffic, passing up everything else and not worrying about it and getting there. So you would send like a signal out to the system that says, here's the new corridor, everybody else avoid. But you would need the testing, you would need the data to show everybody involved that that's a foolproof system, and now you're not just causing chaos and sending aircraft into windows, and things banging into each other, right?
Navigation preemption. It's like it's an emergency.
Absolutely, and it goes back into the automated systems with non-automated systems and how do they interact, and that sort of test and evaluation and iteration is what we really need to be getting after, like right now.
Yep. Feng, I think there's a research grant in there somewhere.
Well, we have been talking about the research idea a lot, but I wanted to point it out to one thing. Actually, Dwight actually mentioned in his presentation. I would say the STEM education will be something we should put a lot of efforts and put a lot of people in, because the thing is we need educated, we need qualified and people to work to build. As an engineer, we build, and not only for today and for our future. So that's why I'm a researcher, and my job not only just teaching certain number of courses for the university, and also another job is to bring research dollars to the university. That's required. And I also have this kind of responsibility, I believe, to reach out to the high school students.
Yeah.
So I did the summer camp when we were still busy in our agenda, and also the COVID-19 still going on. And we had I have been done this for more than 10 years, and the summer camp, we just reach out to high school students, also the minority students, just bring them to campus to show them, expose to them the education opportunities in transportation engineering. Just treat them as college students. And this year we bring them to the dorm, and the students so love, and the parents are so appreciate. And you know, I'm busy, and we have tons of work to do, and everything put aside. And I also have a group of faculty members on Texas State University. They all committed to their time to teach the students. And one day you will find out the students send an email to you and saying, you impacted me, and you impacted my life. And one parent, the parents, we also got an invitation from one student family to the party and celebrate the student got into UT civil engineering. That's okay. Not Texas State, but UT is also okay, right? Eventually they will become
an engineer.
Engineer, right? And a transportation engineer. So one student tell me, I'm already knock on the door. I'm already in Texas State, civil engineering. And he also convincing other students to come in. So this is the way we can convince students, more future engineers to be here, because we wanted more qualified people to build.
Now, the fascinating thing about that is, Andreas, you've got to figure out how to create the same excitement he's creating for transportation engineering for power system engineering. I mean, when you think about, there's a whole other story there. But I know I know we were almost back on time. We're off time. I wanted to know if I can ask a couple, if anybody has any questions from the audience. We do have a question. Is that okay, Andres?
Sure.
Okay.
Quick questions. Some of it's been answered already when I just gave it some time to develop. I was kind of going to ask Darran on the whole idea of the corridors as it was done. Seemed to me like, between the two-dimensional, three-dimensional, four-dimensional, however this develops, TXDOT is in charge of highways and builds highways. Seems to me like you've got to do the same thing in the air, eventually, and be responsible for how innovators and businessmen even think about what they're going to do. Because I'm an innovator and a businessman, and deliver me from people that say, just like I was in college, Michael, you can do anything you want to do, you can be anywhere you want to go, just do it. And they didn't tell me how. They didn't tell me what, and they didn't give any specifics on that, and that was frustrating to me. To me, if you're going to build innovation, if you're going to do innovation, you're going to spend your time and your life and your money on it, well, give me some air highways to think about. Give me some things to develop towards so that I'm not wasting millions of somebody's dollars on something that's never going to exist that I'll never be able to use. Yes. And secondarily, for Dwight, sure, we have air cars, if you like, VTOLs at this point. Is there some sort of transition from the infrastructure we currently have, call them hovercrafts more than really air flights, to use what we have to eventually take to the skies? And is there the innovation properties and the transition to go from that and spend our money using the existing to when hopefully Darran develops something else that they can take off higher? Those are my questions.
It went to you. We'll start with you, Dwight.
All right. As far as the highways in the sky, I think that we all agree on this panel that, yes, we're working towards doing that. I think it's really important to have designated lanes, different tiers for air traffic, whether it be drones at Paragon, we build our own UTM software for traffic management in the sky. So we're developing our own system. And I can say from our platform, we've separated things. So for light package delivery, we did that in a different tier because it can't be in the same airspace as a VTOL would be in another aircraft. And then as far as the aircraft, the VTOLs themselves, you are correct. You take the traditional grid and you just bring it up to the troposphere. And then you create your designated platform based off of that, your different lanes, your rules, your principles. But you've got to test that out. And so starting with the smaller drone delivery, we can at least develop that tier and figure out what makes sense, because the data is what's going to be important to Darran to be able to figure out, is this thing reliable and consistent, or is it something that it's not practical? To your second question, with regards to the crawl, walk, and run, the ramp-up approach, what can we do? We're already doing that. So helicopters are actually the first form of a VTOL. Most people don't realize that. And then, so this will go to the next level in that aspect. So what we're doing as Paragons, we're gonna do a cargo delivery drone, heavy cargo delivery, before we do passenger delivery. Because I feel it's important to get that data as well without putting human lives at risk.
A little less liability with.
Oh, yeah.
Yeah. Am I allowed to take one more question? She walked all the way up there and everything. Is that okay?
Well, I'll just add, so within our authorities, we are working on this. You know, I mentioned general aviation, so we help build the airports and maintain and upgrade the general aviation airports for the entire state. The commercial airports are owned by FAA, but as we said earlier, we don't have airspace management. That's a federal authority right now. But we're aware of the potential of somebody having at least support to that mission. And we also are aware of, as we talked about, these air corridors and highways, and so we're having the conversations with people just like this to understand what might we be expected to do, what would help enable it. And the first question I answered today was digital infrastructure. So where I can begin to enable digital infrastructure that not only looks down at ground-based systems but also covers the airspace above them, we're putting it, and we're working to put that in place to enable both.
All right. Well, thank you, Darran. Sorry for cutting you off on that, man. Boy, Andreas is.
We're way over, but
Last question from our deputy city manager. Yeah, we'll take one last question, then you get a 30-second break.
It's not a question. It's more of a comment. Because I would say, with regard to TXDOT managing something like that, I think that the whole premise for TXDOT is completely different, because it's really looking at terrestrial right-of-way management, the fact that you have utilities on the ground and you have to kind of skew it. And this way, if you're thinking Resakas or waterways or greenways, it's a very different perspective. You may be way more efficient, more safe, and so I would challenge the thinking that you really just take a highway and then put it to the sky. I would actually, as an urban planner by profession, I would say that may not be the most efficient. If it's a straight linear path, probably, but if you want to go, but that may not be the right path. And so I would ask to challenge the thinking, and what's the most efficient way to do it, and include us and include cities in the conversation.
Good. A little tension there between the municipal and the state.
No, she's right. I mean, so some of my background.
No, there's supposed to be tension.
No,
Come on.
I use the highway just for understanding more so. But I mean, some of my background is airspace management, so it's a much more. And to Andre's comment earlier, it is 4D. It's not just there is a time component to managing the airspace as much as there is a dimensional.
Yeah, now I got to figure out what 4D chess looks like for the next picture. I don't know. Well, we could keep going. They're all available here. They've already cut me out, so if you guys can get in between them and have a conversation with them, best of luck. And let's give it up for my panel.